Bismillahirrahmanirrahim. Assalamu alaikum. Iyyaka na'budu wa iyyaka nasta'een. Today the topic of our discussion is about the second lecture of organic compounds, and we come across to the definition that organic compounds are the hydrocarbon compounds of carbon and hydrogen and their derivatives, in which you can see that carbon is covalently bonded. And firstly, we are having that example that CH4 is methane, C2H2 H4 is ethene, and C2H2 is ethyne. They are purely consisting of only carbon and hydrogen, so they are hydrocarbons, but their derivatives are those species which are getting their origin from hydro. Like we are having chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. But we are having another examples where the carbon is there in the compounds, but they are actually, instead of having that carbon, they are still considered as inorganic compounds, like oxides of carbon, like carbon monoxide, carbon dioxide, and carbides, calcium carbide and aluminium carbide, bicarbonates and carbonates. They are also fall in this category. Now we go for the examples, that formula. When we consider the formula of organic compound, we come across to the four formulas: molecular formula, condensed formula, structure formula, and electronic formula. So firstly, we just have a look on molecular formula. Molecular formula, it tells you about the actual number of atoms present in one molecule of the organic compound, and in such case you are having the example of butane, which is C4H10. It tells you that it composed of carbon and hydrogen, and in which carbon is 4 atoms of carbons are there and 10 atoms of hydrogen are present. Second form of formula is structural formula, where we go for the exact arrangement of different atoms of various elements present in a molecule. Conventionally, we go for the representation that when it is singly bonded, it is represented by a single short line, double bond is represented by 2 short lines, and triple bond is represented by 3 small lines. When we go for the example of methane, ethane, propane, and butane, they are having respectively 1, 2, 3, 4, and 5 carbon atoms respectively, and each valency of carbon is satisfied with hydrogen bonds. Condensed formula is the third type, where we indicate the group of atoms joined together to each carbon atom in a straight chain or a branch chain. And it basically, we are having that examples that in case of methane, CH4 is the condensed formula. In case of ethane, which is C2H6, it is represented like CH3CH3. The molecular formula of propane is C3H8, and it consists of 3 carbon atoms, and in one carbon you are having 3 hydrogens, another carbon you are having 2 hydrogen, and in third carbon you are again having 3 hydrogens, because these central carbon is attached on both sides and it is tetravalent. All the carbons are tetravalent, so terminal carbons are having 3 hydrogens while the central will having only 2 hydrogens. And we go for the fourth example, which is butane, C4H10, and CH3, CH2, CH2, CH3 is representing the whole, which are singly bonded in a linear structure. It's representing the structure of condensed formula of butane. On first carbon, it is having 3 hydrogens, but instead of representing each and every hydrogen separately, we condense them in the form of H3. In second case, we can write as H2, and third carbon is represented with 2 hydrogens at CH2, and the last terminal carbon is represented with 3 hydrogen atoms, but instead of writing separately, we write it H3. So the point to be noted over here is that when we proceed from one successive member of the series, as we are discussing the alkane series over here, the successive member of the series differ by CH2 unit in each and every case. So when we move from butane to pentane, we are having 3 CH2 units over here, but instead of writing again and again, the better way is that we can just go for writing CH2 and then with the bracket 3 outside the bracket, so it representing that 3 CH2 is there in the structure. Lastly, we go for the dot and cross structures, where electronic dot and cross formula. The formula was showing that the sharing of electron is represented by dot and cross, and this is a way through which we can order to differentiate the electrons of carbon from hydrogen. So we are representing all of the 4 electrons of carbon with dot and the one electron of hydrogen with cross. So we are having that 2 examples.